Welcome to our video for Shapes and Designs 1.2 and 1.3 homework support. In particular, we're looking at pages 27 through 33, problems number 10, 11, and 49 through 52. In question 10, I'm asked to think about benchmark angles and which of these benchmarks in particular each angle is the closest to. Again, I'm not measuring here, I'm just making estimates. So in A, I can notice, for example, that this rotation looks like half of a rotation, which would tell me that it's half of 360 degrees, which would be 180 degrees. You might recognize that also as a straight line or a straight angle. In B, I notice here that this looks a little bit like a right angle, so my estimate would be that this is close to 90 degrees. For C, it might help me to sketch in some of the benchmark angles. For example, I can sketch in approximately 90 degrees. I can also sketch in 180 degrees, and that'll help me look at some of the benchmarks that might be approximate. So for example, if I divided this part here into thirds, because I know that I could add 30 more to make 120, about 30 more would make 150, and 30 more would make 180, that tells me that 150 is probably a pretty good estimate of this particular angle measure. In the case of D, I'd like to sketch in here another line to make a right angle, and again that'll help me think about how to break up this space. Again, if I sketch those benchmarks of 30 degrees, 60 degrees, 90 degrees, again here's 0, then that'll help me see that this is pretty close to 60 degrees. Because it's about 2/3 of the way from 0 to 90. In the case of E, I might at first be tempted to look at this right angle. However, I notice that they're actually talking about the rotation or the angle that's happening outside. And so that clues me in that I'm going to do 360 minus 90, which is equivalent to 270 degrees. So this is about 3/4 of a rotation. In the case of F, I'm looking at this here, and I might make another little sketch, for example, and try to think about how this lines up. This is just a small piece here that's missing, and if I think about my benchmarks, I can tell that it's definitely less than 90 degrees. If I add in some other sketches here, for example, for say 30 and 60, I can see that this is even smaller than a 30-degree angle. And I'm asked again for particular benchmarks. So I'm asked, for example, if this is closer to 270 degrees or 360 degrees based on the problem information. So considering 270 degrees would be missing a pretty good chunk, would be missing that whole last 90 degrees here, right? This is a 270 degree angle here. I'm going to say that this one's closer to 360 degrees. It's definitely still missing a piece when I look at that rotation. It looks like maybe a 20-degree piece, something like that, but it's closer to 360 than it is to 270. Looking at G, I'm going to sketch in 180 degrees as well as 90 degrees like I've done previously. And then I'm going to look at this a little bit closer and think, well, this looks like maybe closer to 120 degrees than 150 degrees. So I'm going to make an estimate of 120 degrees. And finally with H, again I'm going to sketch in a line here to make a right angle for comparison. I'm going to sketch in some benchmarks. Again, it looks like this would be about 0, 30, 60, 90. And so I'm going to estimate that that angle is close to 30 degrees. You'll notice on this one here, I'm measuring in a clockwise direction instead of counterclockwise, and that can be okay too. It's just something to kind of be aware of when you're looking at a protractor or different angle tool in particular. But technically I can rotate in either direction. The last part of this question asks me to classify these triangles as right, acute, or obtuse. And so in particular my right angles here, I can see one right angle here in the case of B, where that is 90 degrees exactly. When it comes to acute, I'm looking for angles that are less than 90 degrees. And in this case, I can see 60 degrees and 30 degrees, as less than 90 degrees. So I'm going to note that D and H are both acute. And then I'm going to look at obtuse angles. And obtuse angles I know need to be greater than 90. However, it's also good to note that obtuse angles are really both greater than 90 degrees, but they're also less than 180 degrees. So they're less than a straight angle. So at that point, looking for something that's bigger than 90 but less than 180, I can see that I have 150 degrees and 120 degrees. So both C and G. In problem 11, I'm asked to give the degree measure of each angle. There's a couple different strategies I can use here. For example, in A, I'm asked to find 1/6 of a right angle. I could write the fraction 1/6 and multiply by the value of the right angle, which would be 90 degrees. So I'm going to go ahead and multiply on the top, 1 times 90 to make 90, over 6 times 1 to make 6, and when I solve this out, I get 15 degrees. However, maybe I'm not sure if that's really a reasonable answer. So I might make a sketch going from 0 to 90 degrees and drawing in the sixths. So for example, this would be half. I'm going to divide what's remaining so that I can get 6 pieces. And again, I can think about how 45 would be halfway. And so this would have to be going by 15s in order to get up to 90 in those 6 pieces. So again, 45 plus 15 would give me a 60, 75, and then 90. And so again, I can see if I only went 1/6, I would be going 15 degrees. That answer is reasonable. For B, I'm asked to find 3/4 of a right angle. So again, I could make a sketch going from 0 to 90 and thinking about how 3/4 is going to be bigger than 45 degrees, however smaller than 90 degrees. So I'm talking about this amount right here. And so there's a number of strategies you could use. You could add 90 and 45 together, for example, and divide by 2 to find this exact value right here. You could, again, multiply 3/4 times 90. That would get you to 270 over 4, which would get you to 67.5 degrees, which is that value right between them. So again, that answer is 67.5 degrees. For C, we have 5/4 of a right angle. And so when I look at this, 5/4 of a right angle, 5 over 4 times 90 over 1. When I first look at that, I might think I've done something wrong, because that first fraction is actually an improper fraction. It's a fraction greater than 1. It really stands for 1 1/4. However, it's completely right. It's just I need to be aware that my answer is actually going to be bigger than 90 degrees. And that makes sense, because again, I'm not just going a full right angle from 0 to 90. I'm actually going 5/4. So if I imagine dividing the space between 0 and 90 degrees into fourths, I'm actually going 1 more fourth past that. So I'm expecting an answer that's going to be bigger than 90 degrees. So when I multiply out, I get 450 over 4, and 450 divided by 4 is going to give me 112.5 degrees. Next, I'm looking at D, 5/3 of a right angle. So again, I'm going to set up that 5/3. I'm thinking about how that's a fraction greater than 1. So I'm expecting when I multiply it times 90, I'm going to get an answer that's bigger than 90 degrees. And so 5 times 90 would give me 450 over 3, which gives me 150 degrees. Again, it's a great idea to make a sketch of this to prove it to yourself. The final problems here ask us about full turns instead of right angles. So we just need to be aware of that. For E, I'm asked about 2/3 of a full turn. And so 2/3 times a full turn would be 360 degrees. I'm going to get 720 divided by 3, which would give me 240 degrees. Again, I can sketch that out I can think about how 2/3 of a full turn, right? So I know it's a little bit tricky to see thirds on here, but if I go 2/3 of a full turn, I should be getting into the 240 area here, right? This would be 270. This is 0, 90, 180. So again, 2/3. I'm thinking carefully about what that means. I know it's tricky to kind of visualize the thirds here, but you can imagine them kind of like this. There's 1/3 and 2/3. I'm expecting 240 degrees is reasonable. For F, I'm asked about 1.5 full turns. And so that is actually giving me a clue that I'm not only going around one time, I'm going around an additional half time. So again, I can think about how 1.5 is equal to 3/2. So 3/2 times 360 over 1 is going to get me to 1080 over 2, which gets me to 540 degrees. And again, I can think about making a sketch of that and showing how I'm going around 1.5 times, so 360 degrees, plus an additional 180 degrees to get me to the 540 degrees. In the last set of homework problems, I have some equivalent fractions. And I'm hoping you're seeing here that these, again, are two fractions that are set equal to each other, and I can make sure they're in an equivalent relationship by multiplying the top or the bottom of one side by a number, and that should produce the other side. So for example, when it comes to 1/2 equals something over 360, I can do 2 times 180 to make 360, and 1 times 180 makes 180. You might also be thinking about how half of rotation is 360, right? So that has the same relationship. 1 over 2 is equal to 180 over 360. Next, I'm given 1/10 equals 36 over something else. And so again, using a similar strategy, multiplying the top, 1 times 36 makes 36. 10 times 36 makes 360. And so that's my missing piece on the bottom. And again, you can also think about how I could reduce or simplify 36 over 360 and get back to 1/10. Then looking at the next problem, 51, I have 1 over something equals 40 over 360. Again, there's lots of ways to solve these problems, but maybe I want to try simplifying. So for example, 40 divided by 40 would make 1. 360 divided by 40 would make 9. So 1/9, in this case I'm looking for that value of 9, is the same as 40 over 360. You could also think about how 1/9 of a rotation would be 40 degrees out of 360 degrees. And lastly, on number 52, something out of 3 equals 120 over 360. Again, you might want to think about simplifying. 360 to 3. Well, I'd need to divide by 120 to make 3, and then 120 divided by 120 makes 1. So this last missing value is going to be 1. So again, you might think about how 1/3 of a rotation is like 120 degrees out of 360 degrees. That's it for your homework for today. I hope you were able to look through and make sense of your answers, and that you're ready to come with questions that you have for tomorrow so we can discuss this more.